Example 4. If sine A is 3 over 5 with A in the first quadrant and cosine B is negative 5 over 13 with B in the third quadrant, we're going to find the following parts of the problem. Part A, we're going to draw the diagrams for angle A and angle B. Part B, cosine A. Part C, sine B. Part D, sine A plus B. Part E, cosine of A plus B. Part F, the tangent of A plus B. And then part G, in what quadrant does the sum of A and B terminate? So there are multiple parts of the problem. Let's get started with the first one by drawing the diagram for angle A and angle B. The problem provides information that side A, where A in the first quadrant, and side B, where B is in the third quadrant. We're going to draw two diagrams. The first one, in the first quadrant, the side, which is y over r, y is 3, and the r is 5. So the y is 3 and the r is 5. Therefore, the x gonna be the value 4 using the Pythagorean theorem. This is an angle A. And an angle B located in the third quadrant. Similar way, the third quadrant, the cosine is x divided by r. That means the x equals negative 5. So negative 5. And the r is 13. Therefore, the y since in the third quadrant, the y going to be negative as well. The y will be negative 12 using the Pythagorean theorem. Or if you recall the three numbers to form the right triangle as 3, 4, 5, and the other one is 5, 12, 13 as a set of three numbers to give you the size of the right triangle. So for an angle B in the third quadrant, the y is negative 12, the x is negative 5, the r is 13. Where an angle A in the first quadrant, x equals 4, y equals 3, and r equals 5. Now, we're going to use information that we got from the diagrams from part A to answer the following parts of the problem. For the cosine A is x divided by r for an angle A. X in angle A is 4 and r is 5. So we get cosine A as 4 over 5. For the sine B is y over r. Y of an angle B is negative 12, where r is 13. Now we get sine B as negative 12 over 13. The next part, we're going to use them to find sine of A plus B. I'm going to draw the triangle for the AB, for the angle A and angle B again. For an angle A, so this one, as you see, the base, which is 4. So this is going to be 4, and this is 3, and this is 5. And for the B, in the third quadrant, we got negative 5, negative 12, and 13. Negative 5 here, negative 12, and 13. That's for angle B. Then for the sine of the sum of A and B, using the sum formula for the sine function, which is sine A times cosine B plus cosine A times sine B. I'm going to make some room here a little bit. Okay, then replace it, the sine of the A, which is the value 3 over 5. The cosine of the B is negative 5 over 13. The cosine A is 4 over 5. The side B is negative 12 over 13. Now we're going to simplify the numbers. Both products, they have the common denominator as 5 times 13 or 65. So the numerator will have the sum of negative 15 and negative 48. And that comes out to be negative 63 over 65 as the exact value of sine of the sum of A and B. The next part, we're going to use the same information to find the exact value of cosine A plus B. The formula of the sum of the cosine is cosine A times cosine B minus sine A times sine B. From our information, the cosine A is 4 over 5. The cosine B is negative 5 over 13, where the sine A, excuse me, the sine A is 3 over 5. The sine B is negative 12 over 13. And simplify the numbers with the same denominator. So 5 times 13 is 65. The first term of numerator is negative 20. Second term is positive 36. Simplify the number to be 16 over 65 as the exact value of the cosine of the sum of A and B. For the next part of the problem, which is the tangent of the sum. The tangent of the sum of A and B follow the formula that is the tangent A plus the tangent of the B, all divided by 1 minus the tangent A times tangent B. And from the diagrams of A and B, the tangent A, which is opposite over hypotenuse, no, opposite over adjacent, sorry, going to be 3 over 4 for the A. And then added by the tangent B, which is negative 12 over negative 5. That becomes positive 12 over 5 anyway. We're going to simplify it later on. Divided by 1 minus the tangent A, which is 3 over 4. And this we just rewrite it as positive side. Multiplied by 12 over 5. And simplify the numbers. For the numerator, we have the common denominator as 20. And the numerator will be the sum of 15 and 48. For the denominator, we have 1 minus this. You can rewrite as 36 divided by 20. And that will give us negative 16 over 20 for the fraction of the denominator. And now we're going to rewrite it as the nice fractions, like get out of the complex fraction. By the way, the numerator, we get 63 divided by 20. So basically, we have the complex fraction of 63 over 20 divided by negative 16 over 20. When you divide, you can rewrite as the product of the reciprocal or multiply by the reciprocal. Then we get 63 over 20 multiplied by 20 divided by negative 16. And then 20 and 20 can be reduced. And the number is simplified to be negative 63 over 16 as the exact value of the tangent of A plus B. The last one, we're going to determine which quadrant that the A plus B terminated. As you see from the information in part D, the sine of A plus B comes out to be less than 0. The cosine of A plus B is positive in sign. And also the tangent of A plus B is negative in sine. For the quadrant that the sine positive or sine negative but cosine positive, this is going to be quadrant number 4. So we can say that the A plus B, which is the angle, terminates in the 4th quadrant.